Let's do problem one. And once we're done with the problem, I'm going to give you two similar problems that you could do. Okay, let's start. The eight-pointed star shown in the figure below is a popular quilting pattern. What percent of the entire 4 by 4 grid is covered by the star? Okay, so it's not very challenging. So first, what is the entire area? We know it's a 4 by 4, so of course the area of the square is 16. And what part of this, okay, is covered by the star? So we know two of these together, right? They will become one full small square, right? So let's just count them. One, one, right? This one and this one, two, three, four, right? This one and this one, five, these two, six, seven, and then eight and eight. So every two was one, right? Every two of the triangles. So that we know that the total area of the square was 16, right? And now the areas of these segments together is 8. So that's 1/2. And we know that 1/2 is also equal to 50 over 100. So that is 50%, isn't it? Okay, so the answer is going to be 50%. So we're going to choose this one. Now it's time that I give you the problems I told you. Okay, this would be the first similar problem. Okay, you could pause and then do the question. So now this is the second similar problem. Okay, once you have the answers, you could comment them below. Okay, let's do problem two. I'm going to give you one similar problem after doing this. Okay, the table below shows the ancient Egyptian hieroglyphs that were used to represent different numbers. For example, the number 32 was represented by the hieroglyphs like this because we know this is a 10, 10, 10. So that's 10 plus 10 plus 10 equals 30. Okay, or we could say it's 3 times 10. That's again 30. And you have 1, 1, 2. So plus 1, that's like a 32 now, right? So that's how they count it. Now, what number is represented by the following combination of hieroglyphs? Okay, so we just have to go to the table. This shape is this shape. That's 10,000. I'm going to write it here. So 4 zeros. And this is 100. I have 4. 4 times 100 is 400. So I'm going to write it like this. I have 2 of this. So 20. And we have 3 of this. So all we have to do is add all of these up. So of course the unit digit is a 3. Then the 10th digit is a 2. The 100th digit is a 4, a 0, and a 1. So 10,423. Now, let's just make our own question. So to make it a little bit more challenging, this is what I'm going to do. I'm going to put 2 of these. So to power of 1, 2, 3 of these again. Okay. So should I make it more challenging or that's okay? Uh, no, I should make it more challenging. Multiply by this. Now this is actually difficult. So this one also involves the order of operation. So are you going to apply the power first and then multiply, or are you going to multiply and then the power? Okay, think about it and write the answer in the comment section below. Okay, let's do this one. I'm going to have one good similar problem you could do after doing this. Buffalo Shuffle is a card game in which all the cards are distributed evenly among all players at the start of the game. When Annika and three of her friends, how many friends altogether? Like how many people playing the cards? Four, Annika and three friends. Play Buffalo Shuffle. Each player is dealt 15 cards. So how many cards there are? We have three players. Annika is also one of them, right? And each person is dealt 15 cards. That means we have a total of 4 times 15 is 60, right? 60 cards. So suppose two more friends join the next game. How many cards will be dealt to each player? So we still have 60. Now, well, the number of players was 3 plus 1, 4, and two more players joined, right? We now have 6 players. So how many cards to each player? That's going to be 60 divided by 6, which is 10. So this is the right answer. Now the similar question will be a little more challenging than this one. Okay, this problem is from Australian mathematics competition, not American. Somewhat similar to what we did. Okay, answer this question and comment it below. Problem 4 is an arithmetic sequence problem. Very, very important. After I do this, I'm going to give 2 questions to you. If you can't do any of them or you struggle with any of them, definitely you need to practice more questions like this, arithmetic sequence problems. Okay, so let's just start doing this. Lucius is counting backwards by sevens. His first 3 numbers are, okay, this is the first number, right? This is the second number, right? And then this is the third number. Okay. What is his 10th number? Okay. So this one is not very difficult. We just want to write them like this to see a pattern clearly. The first number is just 100, right? The second number is 100 minus how many sevens? Only 1. So the third number is equal to 100 minus 7, right? So when you want third number, 2 sevens, right? If I want fourth number, I need to subtract how many sevens from this now? Look, minus 7. I need 3, right? So fourth number, 3 sevens. Now the question is asking for the 10th number. So the 10th number is again 100 minus how many sevens? 9, right? So 9 times 7, this is 100 minus 63. So it's going to be 37, okay? It's going to be this one. Okay. Why do you call this an arithmetic sequence, right? Because it was always minus 7, minus 7, minus 7, right? That's why it's called arithmetic sequence. So it's time for me to give you the 2 questions and you gotta practice those, right? So the first question I'm giving you is going to be this one. Okay, this is the first question. 300 is the sum of 15 consecutive even positive integers. Consecutive means in order, right? Like 2, 4, 6, 8, 10, so on, like even positive integers. That's what happens. What is the greatest even positive integer among them? That's the first question. Okay. Now, the second one. Now, the second question I give you is going to be this one, right? But instead of 10th, you're going to find 15s first. But that's not over. So what I want you to do is the sum. What is the sum of all these 15 numbers? What is the sum of of the first number or the first term all the way to the last term? The sum of the first 15 terms. Okay. If you're good at both of them, then you don't need a lot of practice on this. But if you struggle, definitely practice this topic more. Let's do problem 5. After this, I'm going to give you one similar practice problem. So the answer to this question is just the perimeter of this rectangle. Okay, let's see why. Betty drives a truck to deliver packages in a neighborhood whose street map is shown below. Like this is even important, a street map. Betty starts at the factory F and drives to location A, B, C, and then D. What is the shortest distance, right? We know the shortest distance is supposed to be like this, right? This is the path Betty needs to take. That's the shortest distance. But because this is a street map, right? You're only allowed to go through the streets, right? You're not supposed to go like this, right? That's you're passing like the building. You have to destroy building to go like that. So the shortest path from F we need to go to A and A to B. Look, if from A to B you could go like this, right? You could even go like this. Which one will be longer of the two? They're the same, right? It doesn't really matter, right? Because to go from A to B, you need to go 3 downs and you need to go 1, 2, 3, 4, 5, 6, 7 to the left. It doesn't matter like the order that you go with. So again, for example, I'm going to go like this, then here, then here. For this one, I'm going to go 1 up or maybe like go 1 right, like this, like this. Okay, so let's just see why it's always the perimeter of the rectangle we talked about. Look, right? If I put this, when I move these around, I'm not increasing or decreasing the path that he takes, right? The distance will not change. Okay, so as you see, right, it doesn't matter which path you select. All the time, the minimum distance you travel is this. Okay, so it's going to be 5 for this side, 7 for this side, another 7, another 5. So you could go 7 plus 5, 12, multiply by 2. Of course, it's going to be 24. So the right answer is this. Now it's time to give you the practice problem. This is the practice problem. This is problem 13 of AMC8 2005. Okay, I'm going to answer problem 6 in 2 different ways. One's without the number line, and the second approach is using a number line. Definitely the second approach is better, but let's do it with the first approach, the usual, the classic approach first. So Animish writes the numbers 15, 16, 17, 18, 19. Okay, so after he erases one of his numbers, the sum of the remaining 4 numbers is a multiple of 4. Which number did he erase? So one important question, what is the sum of all of these? What is 15 plus 16 plus 17 and then plus 18? If you add them one by one, you're not doing it right. The answer is the sum of these is the middle number 17 times 5, which is 85. That's the right way. But why is it like that? Because look, this is 17, right? 18 is 17 plus 1. 16 is 17 minus 1. The minus 1, the plus 1 gets canceled. 19 is 17 plus 2. 15 is 17 minus 2. And then look, they all get canceled out. So what will be left is 17 plus 17 plus 17 plus 17 and plus 17, right? So that's why when you want to do the sum of these, right, you're not going to do it manually. You're just going to multiply 17 by 5. So, and then you say we want to erase one of them. You could answer it by trial. We know, for example, so 85, for example, minus 15, okay, is 70. Is 70 divisible by 4? No, 72 is, or 68 is. Minus 16, of course, it's going to be 69, so not going to work. But 85 minus 17, that's going to be 68. So then that's the right answer. Do I like this approach? No. The reason that I don't like this is because the numbers were so small, right? So what is the better approach? I think knowing the numbers and their placements on a number line. Let's just write multiples of 4. Okay, this is an 8. This is a 12, a 16, and a 20. I think that's enough. Look, we just need to know where the numbers fall. Now, let's see the placement of 15. 15 is already here. That means we could say it's 1 less than a multiple of 4, okay, or 3 more than a multiple of 4. That's what we could say about 15, right? So for 15, I'm going to write it here. Now, 16 is already a multiple of 4. So it has nothing extra, nothing more than a multiple of 4. 17 is a multiple of 4 plus 1. So I'm going to write the plus 1. And now let's see. That's interesting. Look, 15 plus 17, right? We already said this is 3 more, and this is 1 more, right? Together they become 4. That means these numbers together will be divisible by 4. The plus 3 and a plus 1 is a 4 again. So that's why, so when you divide this by 4, it's divisible. We're going to have no remainder. 15 plus 17, that is 32. It's divisible by 4, right? So now we're going to continue writing these numbers. So 18 is here, so a plus 2. 19, of course, is a plus 3. Now, if the sum of these numbers is already divisible by 4, then we have no problem. That means the sum is already divisible by 4. Now, let's add them all up. 3 plus 0 plus 1 plus 2 plus 3. That's a 9. Is 9 divisible by 4? No. When you divide 9 by 4, what is the remainder? The remainder we have is just going to be 1. So that means if we subtract away, if we remove a number that has a 1 extra, it will be okay. And that would be 17. Look, if I shoot this away, right? So what is left? A 3, a 2, and a 3. When we add them, 3 plus 2 is a 5, plus 3 is 8. 8 is divisible by 4, so it's okay, right? So then the answer is 17. So, but why this approach is more complicated than the first approach. But why do I say this is a better one? Because what if they give us a bigger question? So the practice problem I want you to do is that I'm just going to change these numbers, right? So instead of 15, 16, 17, 18, and 19, you're going to do these numbers that are right. So the first number is 5 fives. Okay. The next number is 6, 6, 6, 6, 6, 6. And then 7, 7, 7, 7, 7, 7, 7. And then 8, 8, 8, 8, 8, 8, 8 eights, and then 9 nines. 3, 4, 5, 6, 7, 8, 9. So the question becomes like this. Amanish writes the numbers, blah, 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 all these numbers. After he erases one of his numbers, the sum of the remaining 4 numbers is a multiple of 4. Which number did he erase, right? So now You cannot answer this. You cannot add them and then do that, right? So the number line method will come in handy. So let's see, if you cross one of these numbers, the sum will be divisible by 4. Definitely this question is more challenging than problem 6, but it's a good practice problem, okay? So answer it and then leave the answer in the comment section below. Okay, let's do problem 7. Once we're done, I'm going to give you one extra problem to do. So for this question, all we have to do is take this number and subtract 13 from it. So 50 minus 13 is equal to 37, and that's the answer. But let's see why this is the case. So on the most recent exam in the class, 5 students earned a score of at least 95, at least 90, okay? And all the way, how many students earned a score of at least 80 and less than 90? Okay, well, we need to visualize the question first, right? And the best way to do it is on a number line. So the lowest score somebody can take on exam is 0. The max is 100%, right? And for example, this is 80. Okay, good. Now here it says 50 student earned a score of at least 80. That means 50 students are here. How many students are here? Irrelevant. Who cares how many students are here? We have no information. And now let's read, for example, this one. 27 students earn a score of at least 85. So if this is 85, and because it says at least, right? That means 27 people fall here. And we just talked about how 50 people are here. So how many people are here, for example? 50 minus 27. So now let's go see and read what the question wants from us. How many students earn a score of at least 80, after 80, and less than 90, before 90? All right? At least 80, but at the same time, less than 90. So let's go. Here we have about 90%. 13 students earned a score of at least 90. So 13 students are here. And we know 50 people are here. So how many people are here? It's very simple, right? 50 minus 13. Right? That's all we have to do. 50 minus 13 is equal to 37. So that's it. I'm going to give you a more challenging problem. Okay, this is the problem I have for you. This is, of course, more challenging than the problem we did. We need to be able to simplify these two fractions. Okay, and then you will do the question. Once you have the answer, write them in the comment section below, and then we check that together. Okay, problem 8 is an important one. That's why we're going to explore it a little bit before we actually go on and answer it. And there will be one extra question at the end. Well, Isaiah cuts open a cardboard cube along some of its edges to form the flat shape shown on the right, which has an area of 18 square centimeters. What is the volume of the cube in cubic centimeters? Okay, so now let's go. What if the side is just 1? If the side is 1, what is the volume of the whole thing? The volume becomes 1 times 1 times 1, which is again 1. So does it mean the side lengths and the volume are the same? No, because the unit of the side is just centimeter. But this 1 centimeter was multiplied by itself 3 times. So it's centimeters cubed. And what is the area of this, of the area of one of them? 1 times 1, 1. And we have 6 of this. So the area is actually 6, the unit being centimeters squared. Centimeters cubed, just centimeters. Okay. Let's go by the next one. What if this is actually 2? So the volume is 2 times 2 times 2 being 8. What is the area of one of them? 4 centimeters squared. We have 6 of these. 4 times 6, 24. Okay, but you see now, the area they give us is already more. I mean, for one, side 1 was 6, side 2, 24. 18 comes between them. That means the side lengths that we're looking for is between 1 and 2, right? Okay, so let's figure out what that is. So if the area is 18, we need to go backward, meaning what is the area of one of these? 18 divided by 6. So the area of 1 is 3. If the area of one of them is 3, what is the side length? We want a number that you multiply by itself and it becomes 3. What is that number? By definition, that's a square root 3, right? Which is about 1.7, 1.7, almost a little bit more, right? So that's the side length, right? If the side length is now root 3, what is the volume? We just need to multiply it 3 times. Root 3 times root 3, again multiply by root 3. Which option would that be? So root 3 multiplied by root 3 multiplied by root 3. By definition, root a multiplied root a is just a, right? It doesn't matter what that is. It's always root 5 multiplied by root 5 is 5. So this is equal to 3 multiplied by root 3. This is equal to 3 root 3, which is this option. So 3 root 3. Remember, I told you root 3 is about 1.7, right? Almost. So 3 times 1.7 is equal to what? 5.1 something, right? More text. So that means this volume is about 5 and something. This volume was 8. Of course, it's less than 8. So everything we have makes sense. Okay. Now let's go and give you the extra problem. This is the extra problem, AMC8 2022. Okay, of course, it's way more challenging than the one we did, but it's of the same concept. Give it a try. There are many ways to do problem 9. Some of them are rather slow, but some of them are very fast. I mean, the fastest version is 1 plus 12 just divided by 2. Okay, that's the fastest. Okay, but let's go and learn all about this problem. Okay, so Ningli looks at the 6 pairs of numbers directly across from each other. So they gave us one example, like across 2, for example, somebody cannot say 2 and 9. No, the ones that are across. So she takes the average of each pair of numbers. What is the average of the resulting 6 numbers? Okay, let's see. So for example, what is the average of these numbers? 8 plus 2, 10, divided by 2, 5. So the average of this line is a 5. Now, what is this one? What is the average of 1 and 7? 1 plus 7 is 8, divided by 2 is a 4. I'm going to write it before this. And now, let's do a 3 and 9. 3 plus 9, 12 divided by 2, 6. You see, it's just increasing by 1 every time. 4 and 10, it gives us a 7, right? And what is the last one? The last one, these are the this is the biggest pair, right? Which is going to give us 6 plus 12, right? That's going to be 18, and it's going to give us a 9, right? So when I said, what is the bad way of doing this? So it's not wrong, but probably this is not a good way of doing it. If you're doing it like this, you add all of them and then you say I have 1, 2, 3, 4, 5, 6, and then you divide it by 6, you're wasting your time, right? Because look, the difference between these numbers is always the same thing. So the difference is 1, 1, 1, 1, right? So that's what we call an arithmetic sequence, right? So because the difference is the same thing. When that happens, you want to find the average. What you would do is you take this 4, you take this 9, like the first number and the last number, you add them all together, divided by 2. So you only find the average of the first and the last, okay? Which is equal to 13 over 2, which is equal to 6.5, right? That's a lot better. That saves you time, right? This is the best way. But what is interesting, right? The average of these and the average of all the numbers like 1, 2, 3, all the way to 12 is also the same thing as this one, right? So maybe if you knew this, maybe you could have just done 1 plus 12 divided by 2. But I suggest the best one is doing it like this. It's safer. And then you will find the average, like the first plus the last divided by 2. Okay, so I have a question, extra question. Let me show you that one. Okay, this is the extra question. The sum of 6 consecutive positive integer is 2025. What is the largest of these examples? And you're gonna use what I just taught you like that. The average is going to be the first number plus the last number divided by 2. Okay, let's see if we could use that to find the answer to this question rather quickly. Okay, problem 10 is the first confusing problem of AMC8 this year. Okay, let's go and read it and deal with it. In the figure below, ABCD is a rectangle with side lengths of AB5 and AD3. Rectangle ABCD is rotated 90-degree clockwise, right? Clockwise means it's going like a clock, right? Clock goes like this, right? So counterclockwise would be opposite of this, but we're going to go like a clock, okay? Around the midpoint, this is very important, of side DC to give the second rectangle. What is the, okay, so this is enough. And now let's go one by one. I mean, where does point C go after the rotation? Look, this is point C, and we're going to go, look, we're going to go clockwise 90 degrees. So, and look, that's 90 degrees, isn't it? So that means this will be the new position for C. So C will go here and we're going to call it C prime, right? So now let's go. Where does B go? This is further. Look, this is closer, but this one is, the length is more. But again, we're going to go 90 degrees clockwise. It's going to go like this. Right, try to not move it. Okay, so that's what happens here. As you see, this is again 90 degrees. So that's why B goes here and becomes B prime. Okay, let's go and do the other ones here. So where does A go? A is this distance, right? So again, 90 degrees. Let's go. This is where the A prime B, right? As you see again, this is again 90 degrees for all of them. So that is also A prime. So we clearly see that this is D prime, but we're just doing it for practice. So this is D, and again 90 degrees That's again d prime. So you could clearly see why this is the same rectangle. Nothing has changed. So let's go find something. So we know the question said that's a 5 and this is a midpoint. So clearly midpoint means divided by 2. So if this is 5, this is 1/2 of 5. So from here to here is 2.5. Again, we talked about how this is the midpoint and this is the same line, right? So that means this is going to be again 2.5 as well. So now, luckily, okay. So what is the area of this part? This square, 2.5 by 2.5. We know 25 times 25 is 625. So 2.5 times 2.5 is 6.25. But we don't have it in the options. And let's go and read what the question wants. What is the total area in square inches covered by the two overlapping rectangles? So is the question looking for this? Because it says rectangles overlap. Does it mean this area? I mean, no. If they wanted this yellow area, this is how they would word it, right? This is the segment, the region, okay? The area, okay? Overlapped, right? Overlapped by the two rectangles, right? That's how they would actually like word the problem. If they say this, they're looking for this part. But that's not what they say. That's not what they say. What they say is that, what is the total area? First of all, total. Total means add this part to this part. If it's only one part, then there is no reason for them to say total. So what is the total area in square inches covered by the two overlapping rectangles? I mean, this is one rectangle and this is another rectangle, and these are overlapping rectangles, right? We want the total area. So which means the area of this and this, right? Let's highlight it some other way. We want this total area. Let me see if I can go. We want this area and this area. We need to find the green area. Okay, so how to find it? What is the area of one of these rectangles? This was a 5, this was a 3. So 5 times 3 is 15, right? So if we want two of them, right, this is another one. This is again another 15, but this part is being overcounted because part of that and this. So we need to subtract it. So it's going to be that 15 plus another 15, right? But subtract, we need to subtract this part from it. And we saw how this is 6.25, right? The area of this is 6.25. So then it's going to be 15 plus 15 minus this area, because we have counted it 2 times. We need to, okay, minus it by that one. So it's equal to 30 minus 6.25 is 23.75. So the answer is going to be option D. And I'm going to have a problem for you to do, extra problem. Okay, so this is the extra problem, is about rotation. And let's see. So this is the problem about rotation. Square ABCD has side length 6. Point P is the image of vertex A after a 90-degree clockwise rotation about the center of the square. What is the distance from P to vertex C? Let's see how you do this. Okay, let's do problem 11. Usually these Tetromino questions are very difficult, but luckily this one is very easy. Once we do this, I'm going to give you another version of this question that will be a lot more challenging. Okay, so let's go and do this one. A tetromino consists of 4 squares connected along their edges. There are 5 possible tetromino shapes, all of these as you see shown below, which can be rotated, okay, or flipped over. So for example, okay, 3 tetrominos are used to completely cover a 3x4 rectangle. At least one of the tile is an S tile. What are the other 2 tiles? Okay, so this one we know how many squares do we have? 12. So every one of these is 4. 12 divided by 4 is 3, which means we get to only use 3 of them, right? So since the question said that we got to use one of this, I will write it like this to make things easier, right? So to fill this part, look, to fill this part, what do we have that could potentially fill this part, right? The only thing that we have that could go like this is the L shape, this one. And then what is left? L shape. So what is the question one? Okay, at least when it tells you what are the other 2 tiles, L and L, right? It was easy. But let me give you the real question that they could have asked, but that would make the question a lot more challenging. So I would say I'm going to clean this, and I'm going to clean this. With these 3 only, how many ways can we completely cover this, right? So for example, let me just do some of them. For example, if the square is here, L could go here, L could go here. It's 1, right? Or the square is here, L could be here, L could be here. So let's use some of the other ones, like T shape. If there is a T here, well, only L can fill this. And then we have another T here. So count. The moment they turn this into a counting question, like how many ways, that's going to be deadly, right? Even this question will be challenging for me. I have to make sure that I don't make a mistake while counting. So you also do your best and write down the answers you have. Let's see how many you can count. Okay, you may not know, but problem 12 is a Pythagorean theorem question, right? We know, okay, if this is 90° and this is A, this is B, this is C, because it's 90°, we know A is squared plus B is squared is equal to C is squared. And we need to use this to be able to do this question. So, for example, let's read the question first. The region shown below consists of 24 squares, okay, each with side length 1 centimeter. That means this is 1 centimeter. This is 1 centimeter, right? Also, because it said the square. Then what is this diagonal here? What is this 1, 1, right? Let's just write this as C, for example. Then we know 1 square plus 1 square is equal to C squared. 1 square, 1 times 1 is 1, plus 1 is equal to C squared. So 2 is equal to C squared. So C is equal to square root 2. Square root 2 is approximately 1.4. So this length is 1.4. Okay, so let's read the rest of the question here. What is the area in square centimeters of the largest circle that can fit inside the region possibly touching the boundaries? Okay, so for example, I mean, we could go from, if we start from the center, something like this. Yeah, this is definitely not the biggest, right? But what is the radius of this circle? Just 1. So let's see if we can make it larger. Like, I have to keep the center here. See how big it will be. Still, okay, we need to know the first point is touching as it starts to grow, because that will be the limit. As how we could make this longer. See now, what are the first points touching? I think my diagram is not, of course, perfect. Still, it can fit inside, but almost in there. If I make this longer, I think that's the maximum, right? It's already inside, but it's already touching this point, this point, this point, this point, this point, and this point. Can I make it even a little bigger, right? Can no, because the moment I make this slightly bigger, we see, I'm going outside these regions now, right? So technically, that is the radius that is allowed, right? This is the smallest one. So if I have a circle with this length, it's okay, right? So, okay. So what is the size of this, this length? We know this is 1, and this is 1 and 2. So let's use the theorem, right? Again, let's call this one C. So we know C squared is equal to 1 squared plus 2 squared, right? 1 squared is 1, 2 squared is 4. So C squared is 5, right? So that means the value of this length is actually C is equal to square root 5, right? And that is the biggest circle that can fit in here, right? So if this is the radius, the C is also the radius. So it's going to be a square root 5 is the radius here, okay? So now we know we want the area. So what was the formula for area of a circle? It's pi radius squared, right? We already know radius is root 5. Okay. So that's going to be a square root 5. Okay. Square root 5 squared is actually 5. So the answer is just pi multiplied by 5, or we could write it as 5 pi. Okay. So that's going to be the answer. Okay. So let me give you the question. Okay, this is the question I chose for you. The reason I selected it because now you see that again the size of each one is 1, so it's 1. You may want to find, for example, this length. For example, how long is this one? A to C. To find this is 1 unit, 2 unit, 3 unit, 4 unit. 1 unit, 2 unit, 3 unit. So we know, most of you already know, if one, this is 3, this is 4, for example, this line is 5, right? So this question wants the area of this small triangle. Think about it, how you could find the area of this triangle. This is an interesting question. Okay, let's do problem 13 in 2 different ways. Number 1 is going to be quick, and it's very useful for competition tests like AMC8, but you also gotta learn the second approach as well. So before we start, let's make sure we all know how to find remainders. So for example, of course, when 10 is divided by 6, you all know this is how we do this, and the remainder is just 4, right? But sometimes we might get confused. What if the number that we're trying to divide, like 2, you want to divide 2 by 6, but 2 is already smaller. So what is the remainder in that case? So when you're dividing 2 by 6, so how many 2's are in 6? No 2. So, and then we're going to do it 0 times 6. Okay, it's going to be 0 minus 2. So, in other words, when you divide 2 by 6, remainder is still 2, right? But when we're dividing 10 by 6, the remainder is 4, okay? This might be confusing you or some of your friends. We had to talk about it a little bit. So, Now let's go and clear the screen a little bit. Okay, now let's go and read the question. Each of the even numbers 2, 4, 6, all the way to 50 is divided by 7. The remainders are recorded. Which histogram displays the number of times each remainder occurs? Okay, so the quick way now. The quick way is by using the options, right? So for example, look, remainder is 0. Let's see, just find the remainder 0. I mean, what is the number that when we divide by 7, remainder is 0? What's that number? 7 is 1, right? When divide 7 by 7, remainder is 0. But 7 is not here because 7 is odd. What is the next number that is like that? I mean, when we divide 14 by 7, right? The remainder is 0. Okay, so it happened once. So we go here. 14 is the first number. What is the next number that is like that? 21 is divisible by 7, then is 28. So 28 divided by 7 is the next number that leaves remainder. So 14 is the first, 28 is the next, and now plus 14, plus 14, plus 14, right? So, and then the next one is 28 plus 14 is 42. That's still good. So, and then the next one is 56. Oh, 56 is already, okay, greater than 50. So the numbers that we have, okay, that when we divide them by 7, remainder is 0 is only 3, 14, 20, 40. Now let's just go here. This option says 4. Of course it's wrong. This option also says 4 is also wrong. But this one is the right answer. Now let's go find something else. I mean, so this one, all of them are the same. These are all the same, so it's not good. These are all saying the same thing. The third column, all of them are the same. So we need to focus on the differences. I found one. Take a look. This one here says the numbers that when we divide them remainder 3. Here it says 4. Here it says 4. Here it says 3. Let's go and just check those. What is the number that when you divide it by 7, the remainder is 3? What is the smallest number? Smallest positive number that is like that. Okay, you might say 10 is the first number that is like that. When we divide 10 by 7, the remainder is 3. But also 3 is like that. Right? So 3 is like that, 10 is like that, and then plus 7, 17 is also like that. But we want only the even numbers. So 10 is the first number. We just want the even numbers. What is the next? 17 plus 7 is 24. But we only want to keep the even ones, not the odd ones, right? So the first number that is like that is 10. Let me change my color. So because we're talking about this one, 10 divided by 7, the remainder is 3. The next number is 10 plus 14. So 24 divided by 7, 3, 21. The remainder is also 3. And then 24 plus 14 is 48, right? So 48 divided by 7. Okay, sorry. The next number is 38, right? So when we divide 38 by 7, we got to do it like this, 35, subtract, and then 3. That's the number here. And now the next number is again 38 plus 14. Now this number is actually going to be 52, which we're not going to accept. So what are the numbers that when the even numbers that when we divide them by 7, remainder 3? There are only 3 numbers like that. 10, 24, and then 38. So this option says 4 is wrong. This option says 4 is wrong. So the answer is this one. Okay. This was the end of approach 1. So we already know A is the right answer to the question. Okay. So now let's do the second approach. The second approach is also not very difficult. Let's just write the numbers. So 10, 4, 6, let's just write them here. 8, 10, 12, we need to have a lot of them here. 14, 16, 18, and all the way to 50. Now, when you divide these numbers by 7, what is the remainder? We're just going to write the remainder of these numbers when we divide them by 7. 2 divided by 7, the remainder is 2, of course. 4 divided by 7 is smaller, so the remainder itself. 6 is itself. 8 divided by 7, remainder is only 1. 10 divided by 7, remainder is 3. As you see, that's just plus 2, plus 2. 12 divided by 7, remainder is 5. 14 is already divisible by 7, so the remainder is 0. 16 divided by 7, remainder is 2, remainder is 4, and look what's happening. So these numbers from here, that's one cycle. So from 2 to 14, right? We have how many numbers we have? We have 7 numbers, right? Yeah. So these are one cycle, okay? So the next 14 number, okay, is going to be like this. That would be, again, another cycle, right? The numbers will repeat 6, 1, 3, 5, 0. And when this happens, what is the last number here? I mean, look, for the 0, it was 14. What is the next number that when you divide it by 7 leaves no remainder? We already talked about this. The next number is 28. So this is a 14. This number here is 28, leaves the same remainder. We're going to have one more of these blah, 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 blahs, right? The same numbers will happen here. 1, 3, 5, 0. What is the number? The next multiple of 14 is 42. So it's over, right? So every remainder already was 3, happened repeated 3 times. Now take a look. The next number here is 44. 44 divided by 7 leaves remainder of 2, right? So, and then 46, okay, and then 48, and then 50. When we divide them by 7, this one leaves remainder 2, remainder 4, remainder 6, remainder 1. So these remainders, like remainder 2, will happen one extra time, okay? So that's why here, remainder 2, this happens one more time. 46, also remainder 4 happens one extra time. Remainder 6 happens one extra time. And 50, remainder 1 happens one extra time. That's the reason why these repeated. Okay, so we already knew the answer was option A. We did it 2 different ways. And now it's time that I give you the questions to do. So what I want you to do to practice, I want you to draw a histogram yourself, right? You just want to draw one of these graphs yourself. But what you got to do, the last number is 100, okay? And then you're going to go by divisibility by 9, right? So each of even numbers 2, 4, 6 all the way to 100 is divided by 9. You're supposed to draw a histogram like these yourself. That would be the practice question, okay? So that's the end of problem 13. Okay, let's do problem 14. After we do this problem together, I'm going to give you an advanced version of the same question so that you could do it at home. Let's read the question. A number n is inserted into the list. The mean is now twice as great as the median. What is n? Okay, so just to check a few things before we start doing the question. If I have these numbers like 1, 2, 3, 4, and 5. Okay, what is the median? The median is always the middle number. Look, this one cancel with this one, this one, this one. So 3 is left, right? That's the median. Okay, but what if I have even numbers? I mean, what if I add a 6 to here? What is the median now? Look, 1 goes with 1, 2 goes with 5. If I cross 3 and 4, then there would be no number to choose the median from. Because that happens, we say, okay, now the median is the number between 3 and 4, right? If you have a number line here, 3 is here, 4 is here. What is between them? It's 3.5. Okay, that's how we do the median. Okay, and what is the mean? The mean is just the average. Well, technically, for example, if you want to know the average for this question, that is the sum, okay, divided by how many numbers do we have? 1, 2, 3, 4, 5, 6. So that's technically the mean. Okay, now let's go and deal with the question here. Okay, so let's count the numbers that we have. This is our first number, second number, third number, fourth number, fifth number. Before we add the median, before we add n, what is the median? The median would be the third number, right? I'll cross this by this one by this one. 7 is the median, but we need to add a number here. So what if n is to the right of 7? It doesn't matter where. For example, what if my n is here? Now I have 6 numbers. 1, 2, 3, 4, 5, 6. So the average will be, look, this one with this one. So the number, the median is between 7 and 7, so which is technically the 7. In this case, median is 7, right? And for example, what if n is here? Would that change a thing? I already put n here. What if n is between them here? Will that change the median? This one by this one? It's still 2 7s are in the middle, right? But there is also another case here. What if n was to the left? So for example, it doesn't matter where I put it, as long as it's here, it doesn't matter. I'm gonna put, for example, n here. If n is here, let's take this one with this one with this one. Oh, 6 and 7 will be left. So the median will be 6.5. That's also a possibility, right? Okay. But fortunately, the options will help us because they say the n is either 7 or greater. That's why we don't have to worry about this n, right? Because if you put n here to the left, it's going to be less than 7. We don't have it in the options. That's pretty good. So that means n is either here or here or here. In any of these cases, the median, we just talked about it. If n is to the right, the median will always be the 7. Okay, that's very good. So let me write it down. We know that the median is 7. And here it says the mean, the average is twice of that. So the mean will be 14. So we're just going to write the simple equation. We're going to find the average. The average is going to be like this. 2 plus 6 plus 7 plus 7 plus 28 plus n. So how many numbers do I have? 1, 2, 3, 4, 5, 6 numbers now. This is equal to, the mean is just 14, right? Okay, let's add all of these numbers here. 2 plus 6 is 8, 15, plus 7, 22, plus 28, 50. So this is 50 plus n. So I'm going to write it like this. So one thing we could do here, we're going to cross multiply. So by cross multiply, we once multiply these numbers together. 50 plus n times 1. I'm going to write it here because I know some of you will have problems with this. So 50 times n multiplied by 1, that's cross multiplying, is equal to these numbers together. It doesn't matter if I write 6 times 14 or 14 times 6, right? Order is not important when multiplying. So 6 times 14 then. Anything multiplied by 1 is itself. So 50 plus n. And what is 6 times 14? That's a 60 and a 24. Yeah, so that's 84. So n is equal to 84 minus 50. I don't have a space, so I'm going to write it here. N is equal to 84 minus 50. So n is equal to 34. There you go. That's the answer. Okay. So it's going to be like this. So where was n really? N was after 28 because 34 is great. This is the, now we know where n actually is. The n was a 34, which is placed right over here. Now, let me give you a better question, right? The question I'm going to ask you is much more advanced than this one. Give it a try. So I'm going to clean this number. Instead of 28, I'm going to give 50. Let me write it smaller. So I'm going to give you, this number is 50 now. And you're not going to have the options anymore. So what I'm going to go here. So the question is not what is n. So it's just like what are possible values of n. Possible values, okay, of n. So this is what we're going to do now, right? Because I changed the question. Now n could be to the right or to the left. You're going to do it for 2 cases. Okay, now let's do problem 15. Once we're done, I'm going to give you another version of the same question so that you could practice more. Key draws a 6x6 grid. He colors 13 of the unit squares silver and the remaining squares gold. Key then folds the grid half vertically. Okay, so, but I have this piece of paper ready. By folding it, it means it's going to do something like this. And it doesn't matter if it goes the other way around. As long as we're folding it, it's okay. Forming pairs of overlapping unit squares. Okay, so what does that mean? Look, I made this paper. My finger, this hole to this line is the same distance as this line. I hope you see it better. Oh, from this line here to this hole is the same as this distance to this hole, right? That's why if I put my fingers inside these, so, and if I fold it, you'll see that, oh my God, if you see that they kind of like my fingers will touch each other because they are of the same distance. And that's all you need to visualize. If you can visualize it, if you understand the problem, it's a simple counting question, really. So, and when that happens, they form pairs of overlapping unit squares. Now let M and then capital M equal the least and the greatest possible number of gold on gold pairs respectively. Okay, so let's explore the problem better. We know we're going to have, okay, 13 of them silver, okay? And we have 36. 13 of them are going to be silver. So, which means 23 of them are supposed to be gold, right? And then what does the question want? We want the gold on gold pairs, right? We want to pair them up, gold on gold. So now, for example, if I have my silvers here, right? This is a silver, silver, silver. What happens if I put, it doesn't matter, all my silvers on one side? Look that I go random. I just make sure all my silvers are here. 3, 6, 8, 9, 10, 11, 12. I'm going completely random here. So 4, 6, 9, and then 13. Okay, so that means if I put all my silvers on one side, then everything else is just gold, 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 right? So, and now what happens when I do that? We just remember, we want the number of gold on gold. Remember my fingers, right? So when we do this, the golds will be on top of the gold. So let's just go with this one. Imagine you put one of your fingers here and your other finger here, and then you do the same thing, right? So a silver on gold will be together. We don't want to count these, right? So we want to just count gold on gold. This will be on this, right? This on this, right? This one and this one, this one and this one, and then this one and this one. So we're going to have 5 gold on gold. And that would be the least amount, right? Because I put all the silvers on one side. Now we're going to have only 5 golds on one side, and there will, because all of them here are gold, so eventually I'm going to have 5 gold on gold. So let me go here. So we're going to have, so the case of 5 gold on gold. And in this case, I had 13 silvers, right? That means we have 13 silver on gold. We don't want to count those, right? Now, okay, we want to, that's the minimum. So we want to also, this is the minimum value of gold on gold. If you want to maximize gold on gold, what should we do? One way is easy, just say I want to maximize the number of gold on gold. There are a lot of ways to do this. You could say, I put, how many golds do we have? You have 23 gold. Then you start putting 1 gold here and 1 gold here. That would be one way to do it. So we could put, to get gold on gold, if I put one of my silvers here, right? Oh, I want to put them, so if I have 1 silver, my bad. Okay, I fix it. If I have 1 silver here, I'm going to put another silver here, right? I put 1 silver here, 1 silver here, 1 silver here, 1 silver here. So if I fold, I'm going to all these 3 silvers on top of the other silver. So I put 1 silver here, 1 silver here. I just make sure I put 1 silver here, that when we fold, the silvers will be on top of one another. So we get rid of all the silvers. So we have 6, 7, 8, 9, 10, and then 10, 11, and then 12. There will be one extra. There will be 1 extra silver. And now you see the rest of them will always be gold, gold, gold everywhere. Gold, 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 right? So I just put it here so that we just see the answer clearly. All of these are gold. Okay, so in this case, remember, I put 6 of them here. They have their corresponding right over there. This one and this one. So these will get us 6 silver on silver. Right? And what else? This one will get us this silver, and this gold will be together. We're going to have 1 silver on gold. And look, the rest will be always gold on gold. Silver on gold. So because we got rid of all the silvers, whatever is left is gold. And then when we just bend it in halves, then gold will be on gold. So that's 7. Now we know, because we have 36, right? So, okay, when we do the fold, we're going to have 18 pairs And this is already 7 pairs that are not gold on gold. So we're going to get 11 gold on gold. So here the maximum will be 11 gold on gold. So it's also very easy. You just count for yourself and say, okay, this gold, okay, will be folded onto this. This gold onto this gold. This gold onto this gold. Just can count for yourself too. That's going to be maximum 11 and then minimum 5. Okay. So now let me give you the different version of the question. So all we do here to give you a little different variant of the same question, I'm just going to clean this number and we're going to change it by an even number, a big even number, like a 20. So we're going to have 20 and then, but the rest of the question is just as is. I'm not going to change it. So, but the answer may not be of the options. So that's why I cleaned them. So that's enough. Let's do the next question. Okay, let's do problem 16. Problem 16 is very easy if you manage to understand what the question says, right? Now it's all about reading and understanding it. 5 distinct integers from 1 to 10 are chosen, okay? So distinct means what? So for example, can I choose one number more than one? So for example, can I choose 1, 2, 3, 4? 4. Can I choose one number twice? No, because it says distinct, right? I would choose 1, 2, 3, for example, 9. Okay. And 5 distinct integers from 11 to 20 are chosen the same way. Now this is again another weird part. No two numbers differ by exactly 10. What is the sum of the 10 chosen numbers? So for example, let's just write here numbers. Like if I have 1, what is the number that differs by 10 from 1? That's 11, right? Isn't it? So what is the number that differs by 10? Okay, from 2. So it's going to be 12. Okay, so 3 and 13 have a difference of 10. 4 and 14 have a difference of 10. 5 and 15, 6 and 16, 7 and 17, and finally 8 and 18, 9 and 19, and finally 10 and 20. Okay, so these are the numbers. It says choose 5 distinct numbers, right? I mean, I could choose this one, this one, this one, this one, this one, right? Anything you could choose here. For simplicity, I mean, it makes sense to choose the first 5. If I choose this one, for example, 1, that means I can't choose 11. If I choose 2, I can't choose this one. I can't choose this. So if I choose the first one, right? Now, when I go to the other numbers, when I want to choose from 11 to 20, I'm forced to choose these. But the strange thing is that it doesn't matter what 5 numbers on the top you choose. The sum is always the same thing. Think about it, why this is. That's the question about this one, this question, like extra question. So now, how do you add? Technically, could just go 1 plus 2 plus 3. There is a faster way of counting this. What is 1 plus 2 plus 3 plus 4 plus 4? We have 5 numbers and the middle number is 3. So the sum is 3 times 5 is for this one. Now again, we have 5 numbers, 1, 2, 3, 4, 5. The middle number is 18 and I have 5 numbers. So the sum is 18 times 5. That's 19. So the sum of everything is this 15 and this 90 together, which is 105. So the answer is this. And the extra question that I leave for homework is think about why that it doesn't matter what 5 numbers you choose on the first row and what 5 numbers you choose from the second row. The sum will always be 105. Why is that? If you can't do this problem, but you know how to add fractions and you know how to multiply fractions, so the reason you can't do this problem is not your math, but it's actually a skill that we need to be able to read and understand and comprehend the question. So let me show you something. So let's just go through fundamentals. The fundamentals that we need to have in order to be able to do this question is being able to add two fractions like this. And one more thing. Imagine you have a classroom with 100 students in it. 1/4 are girls of those students. How do you find them? You could do it by multiplying, right? You could say 1/4 multiplied by 100. This is equal to, you could also write it like this. 1 times 100 is 100. 1 times 4, that's 25. So 25 are girls. That's one thing we need to know. Okay. And the other thing we need to know is actually how to add this. I'm pretty sure most of you know. Okay. We just need the common denominator. This has been multiplied by 5. This has been multiplied by 4. That's all the math you need, right? So now let's go and read the problem. It's all about reading and comprehending it. Let me undo all the work back to where we were. So let's go and read the problem here. There you go. In the land of Markovia, there are 3 cities, A, B, and C. There are 100 people who live in A. Okay. And 120 who live in B. And 160 who live in C. This is important. Everyone works in one of the 3 cities. Okay, that means everybody has to work. And a person may work in the same city where they live. Okay, so it's just giving too much information. In the figure below, an arrow, okay, pointing from one city to another, like this one, is showing what? For example, like this. Is labeled with the fraction of people living in the first city who work in the second city. For example, right, this example. So for example, how many of people B go to A to work? 120 times 1/3, right? We already saw that. That's just 40. Okay, so that's all we really need to understand about this. So what does the question want from us? Okay, how many people work in A? Okay, so there are 3 groups who live in A. Some of the people in A go to B for work. Some of people in A go to C for work. There's a 3rd group. What is that 3rd group? They're people who don't go anywhere, right? They're people who don't go anywhere. So of these 100 people, okay, so a lot of them leave. Let's see how many people leave from this 100. 100 times 1, 4. Okay. We just saw that. This is equal to 100 over 4, which is equal to 25. So 25 people, okay, left A. Okay, they leave A. Okay. And now of these 100 people, let's see, 1/5 of them already leave, right? This is equal to 20. So what happens to the rest of the people? So 25 left, 20 people also left. So how many people stay in A for work? That's going to be 100 people were there, minus 25 minus 20, which is equal to 55. So 55 people don't go anywhere. So that's one part of the answer, 55. But also, there are people from other cities who go to A for work. So for example, from B, 1/3 of the people go to work in A. So 120 times 1/3, which is equal to 120 over 3, which is equal to 40. There you go. And there are people who go from C to work, right? That's already 160, and 1/8 of them go to A to work. This is equal to 160 over 8. We could simplify, and the answer is just 20. So from C, 20 people go to A for work. From B, 40 people go to work. And there are 55 people who are already in A. They live in A and they work there. So we just need to add them all up. This is 60 plus 55, which is equal to 115. Let me write it this way. Okay, so the answer is just 115. Okay, that's it. So let's just give you one question to do. Just tell me the number of people, the same question, instead of A, make it B. Okay, that's one question that I give you. Find the number of people who work in B. And I have another question here. What is the sum of people who work in A, B, and C? Who work maybe in A. Okay. In B and C. There is a way to answer this question in 10 seconds. Can you find it? You could answer this question. One way would be, we just found the number of people who work in A. We could take the same amount of time to find the number of people who work in B. Again, the same amount of time to find people who work in C. But to find the people, the sum of the people who work in A, B, and C is a 10-second question. Do you know why? Doing problem 18 the right way should take about 30 seconds, 40 seconds. If it's taking us more, that means we're not doing it right. So the right way is doing it by similarity. But before I actually explain how to do this one, we need to have some introduction. We need to understand what we mean by similarities and how to use it. So let's have some space. Let's go and learn more about similarity, and then we come back and deal with it. So if we have two squares like this, the ratio of the side, for example, the small one is 1. The bigger one is actually 2. Right? The ratio of the sides is 1 to 2. What is the ratio of the areas? Right? So the sides are 1 to 2. The areas is what? This is going to be 1 times 1. This is going to be 2 times 2. So 1 to 4. That's going to be the ratio of the area is going to be 1 to 4. Okay? Let's go and deal with something else. So for example, what if we have a rectangle? So let's see, this one is 1 times 2. Okay, let's go and make everything 3 times larger. So let me draw it here. The side length here will be a 3, and then this one is it's actually going to be like this. If I want to make it 3 times larger. So this is going to be 1 times 3. So this is 3. This will become, let's make this one 3 times larger, so it will be 6. Okay, pay attention that if I write 6 over 3 and we simplify it, it's still going to be 2 and 1. So the ratios are the same. And each side has become multiplied by 3, isn't it? So if the ratio of the sides is 1 to 3, what is the ratio of the areas? Sides, areas. The ratio of the areas will be 1 squared to 3 squared. Whatever we have here, we just square it, and then we get the ratio of the areas. That's how it works, right? So let's go and just do it. What is the area of this one? 1 times 2 is 2. Good. The ratio of this one is 3 times 6, 18. And if we divide 18 by 2, we realize that the ratio of the areas is just 1 to 9, right? This becomes actually a 9. So the ratio of the areas is actually 1 to 9, right? So we were right. So let's go and practice it more so we completely understand how it works. So let's go with the circle now. So for example, let me draw a circle here. So let's see, for example, the ratio, this is the radius is 2, the radius is this one 3. What is the ratio of the bigger area to the smaller area? So for example, this is a 2. Okay. This one here is a 3. Okay. So the ratio of the sides is 2 to 3. Now, this is for the sides. We just need to square them. What is 2 squared? 2 squared. 2 times 2. So 2 squared is 4. 3 squared, 3 times 3 is 9. So this is the ratio of the areas. Let's go and check it. So we know that when we do area of a circle, so it's pi r squared, which is equal to pi times 4 pi. And this one is equal to pi times 3 squared, which is equal to 9 pi. Now, if we divide them here, let's just go write it here, for example. Let's write it here. Let's put a line here. So we have 4 pi to 9 pi. Let's divide both sides by a pi to get rid of them. So you see now the ratio of the areas is really 4 to 9. So let's also apply this to triangles as a question here. So for example, imagine we have two triangles, and these triangles are similar. Okay. So I'm trying to draw them similar. So now if this one, for example, is equal to 2, this one is equal to 5. And the area of this one, all of this is A. What is the area of this one? That's the question, right? So we know that the ratio of the sides is 2 to 5. Okay. And we know this is for the sides, but not for the areas. To get the ratio of the areas, we need to square both sides. Okay, so it's going to be a 4 to 25. Okay, so now this is the ratio of the areas. So now we could divide or multiply both sides by any number we like. So for example, let's divide both sides by a 4. So this is going to be 1. This is going to be 25 over 4, right? So now if the area of this one is A, the area of this one is 25 over 4A. Ooh, right? So this is the ratio of the areas. Oh, let me see if I can block it. So this is going to be 25 over 4A. Now let's just change the side length so that we practice it more. So what if, okay, the ratio here is 1 to 3. Okay, so if this one is a 1, this one is a 3, what is the ratio of the areas if this one is A Okay, this one is 3. So the ratio of the sides is 1 to 3. Let's just square both of them. 1 times 1, 3 times 3. So that means if this one is A, this one is 9A. And let me show you graphically why this is also correct for triangles. Look, this is a 1, right? So let's just find this side here. And then I'm going, this is for example the 1. I'm going to draw this side now. Look, that's the A, right? So I'm going to do again, find another 1 here. Okay, so I'm going to draw this one. And now let's go and draw the parallel lines to this. So it's going to be this one, right? This is also this one. This is again the red one, right? You see what I'm doing here, right? So, and then, so from here, again, I have to go similar here. Then I'm going to go like this here. So you would see this is almost correct because the triangles we drew are not perfectly similar, but you kind of get the idea here why the ratio is 1 to 9. And my drawing is not perfect. This is 1A, this is another A, this is another A, this is another A. Oh, we still need to have another green one here as well. So another A, another A, another A, another A, another A. So we clearly see why the ratio works like this. Okay, so now let's go and apply what we learned to the actual question. So we're going to do it really quickly. The circle shown below on the left has a radius of 1 unit. Okay, we could see that. The region between the circle and the inscribed, a square is shaded. So it's talking about this part around it. Okay. In the circle shown on the right, 1/4 of a region between the circle and the scribe is shaded. So it's going to be this one. The shaded regions in the two circles have the same area. Let's go. Let's call this a smaller part. For example, this one is A. So this one is also A. This one is also A. So this one is also A. But it says this one, all of this is equal to that. So on the left we have 4A. So on the right, we're supposed to have another 4A. Now take a look. These are similar, right? A circle and then a square inside. Of course, they're similar. And this part and this part shows that this one is 4 times of this one. But what is 4 times? The area. So that means the ratio of the area of them is 1 to 4. So the ratio of the areas is 1 to 4. So what is the ratio of the sides? It's just 1 to 2. If we square the sides, 1 times 1 is 1, 2 times 2 is 4. So what does that mean? If this is 1, this is 2. So if you get good at this, you don't even need to write anything. You could just do it by looking, right? So the ratio, so this is just 1 to 2. It's asking for the radius. The answer is 2. So if you're good, you could maybe do it in 10 seconds, in 15 seconds, right? So, So before we move on, I'm going to give you a more difficult version of the same question. So it would be this. The same question, okay? But instead of circles, we have spheres. That means that the question is no longer 2D. Let's assume everything is 3D. So these are like balls, not a circle. But everything else is the same. So that means the volume of this part is A. The volume of this part would then be 4A. Then what would be the radius? It's not going to be the same thing. That's why I have to remove the options. If you know, this is not an easy question. If you know the answer, write it in the comment section below. Okay, let's do problem 19. Problem 19 is not very difficult to understand, but to do it, we need a little bit of algebra. And my advice to you is this. When the question has a lot of parts like this one, a lot of information, you read it more slowly, right? Not the other way around. So let's go and read it. We have two towns, A and B, that are connected by a straight road, 15 miles long, traveling from town A to town B. Okay. The speed limit changes every 5 miles. So 25, 40, and then 20. Two cars, one at town A and one at town B, they start moving toward each other. So like this. Okay. At the same time, they drive at exactly the speed limit in each portion of the road. How far from town A and Maz will the two cars meet? Okay. So the meeting point, is it in the middle, more to the left, or more to the right? Think about it. If they were going with the same speed, it would be in the middle. But we could see the two numbers are different, so it's not going to be in the middle. Where would that be? It's going to be more to the right. And the reason being that this car would go faster than this. So it will finish the 5 miles before the other car. So when A is here, B is here, not there yet. So A will have more time to travel. So of course, then this one have little time. So they're going to meet somewhere there. And that's it. So we also know that a speed multiplied by time is equal to distance. Do we need to memorize it? Absolutely not. Look, so for example, if you run with the speed of 5 meters per second, and you only run for 1 second, how far do you go? 5 meters in 1 second? 1 second, 5 meters. That's it. If your speed is 5 meters in 1 second, and then you run for 2 seconds, you go 10 meters, right? 5 meters in 1 second, 5 meters in another second. So very simple. Nothing to memorize, it's common sense. Now, we need variables for the speed. Let's go with S. For time, let's go here. For distance, we're going to go X, not D. No reason. So now, the important thing is here. The two cars start at the same time. They get to each other at the same time. So they travel for the same amount of time, right? So, and that's really important. So let's divide both sides by S. So we're going to get time is equal to distance, right? Divided by speed. That's all we need, isn't it? Okay, so let's write it's for X, for A, sorry. This is the meeting point. We need to know how far A goes. A goes for a 5. And then this extra part, do we know what that is? Of course not. This is just going to be X, right? So let's change the color so that we reinforce it. So let's go, for example, this one is just X, right? So the distance the car A goes is a 5 and an X. So we have the distance. We need to divide it by the speed. So divide it by 25 or 40 because the speed's changing. None of them, right? Because for the 5 miles, we went with the speed of 25 and with the X with a different speed. So the way I wrote it was not correct. I need to write it this way. The first 5 miles, we went with the speed of 25. So let's simplify this real quick. 5 over 25 is 1 over 5. 1 over 5 of an hour is 1 hour divided by 5 is 60 minutes divided by 5 is 12 minutes, right? So that's going to be more like 20 minutes. Plus, and then for the next x part, we're going to go with the speed of 40. That is for the time for car A. For car A. Now, all we have to do is write it for car B. Okay, so the same thing. We're going to go. The distance was 5. The speed is 20. 5 over 20 is 1 over 4. 1 over 4 of an hour is 15 minutes, right? So the other car, 12, this one, 15 minutes plus. Now, what is this distance? Look, we know from here to here is 5. So if I go 5 and x, if I subtract x from this 5, then we're going to have this red part. So the red part is just 5 minus x. So we're going to write 5 minus x. What is the speed? Again, 40. This is going to be speed for, this is going to be time for car B. Time for car B. So it's over, right? We don't even need the diagram. We just need to solve this thing. So you could just solve the equation the way you like. I'm going to do it the way I like. I would simplify these first. This is going to be 1 over 5 plus x over 40. I'll divide them again by 5. That's going to be 1 over 4 plus 5 minus x over 40. So I don't like the fractions, and I think you don't like the fractions too. So what we would do, we would multiply everything by the least common multiple of these. What is the least common multiple of 5, 4, and 40? Right. The answer is just 40. So, but why do we do that? You're going to see why. So we're going to multiply this one by 40, right? This will multiply by 40. Everything multiply by 40. This will be 40 over 5. That's going to be just 8. So I'm going to just write 8. Plus. This one is, again, I'm going to multiply this by 40. Look, it's going to be 40 times x divided by 40. Of course, these two will cancel. So then this will just becomes blah, blah, x. Now, this one multiplied by 40 again. So 40 times 1 over 4, they cancel, just a 10. And then finally, again, we multiply this by 40 again. Blip, blip. They also cancel each other. So what is left is just 5. Oh, I cleaned too much, didn't I? It's going to be just 5 minus x. There you go. You see, by multiplying all of these 4 terms by 40, we managed to get rid of all the fractions, and that's what we want. So now let's go here, take x. So I think this one is easy. You will just do it whatever x goes here. So we're going to have 2x. The other side is going to be 10 plus 5. This is going to be minus 8, right? So this is just 7. 2x is equal to 7. So x is just equal to 3.5. And that's what we wanted, isn't it? Look, the question wants, how far from town A? This is a 5 plus an x. So the answer is just 5 plus x, which is equal to 5 plus 3.5. So the answer is just, the answer is just 8.5. There you go. Okay, so before we finish this question, let's just see. My question to you is, we did this for the distance. How many minutes does it take for the cars to meet? So do this one. For your homework, extra question, find the time it takes for the two cars to meet. Okay, again, it's going to be a decimal value. That's a good practice. Let's do that one too. Okay, let's do problem 20. Two different ways, and both of the ways will use middle school algebra. Nothing too difficult about this question. So S, Dev, and R are sharing a large block of cheese. They take turns cutting off half of what remains and eating it. First, S eats half of the cheese. So let's also make it easier by visualization. So let's draw the cake or the block of cheese. It doesn't matter which one it is. And S would eat 1/2 of it, right? So 1/2 of it will be eaten by S, right? And then after that, it's time for Dev to eat. 1/2 is left, right? So Dev will eat this part, right? So it's 1/4. And then for this person, it's time for R to eat. R will eat exactly 1/2 of it, right? So this is 1/4, right? And R is going to eat half of it. That's going to be 1/8 for R. And the same thing will go on, right? After everybody eats for one turn, you could see only this slice is left, which is 1/8. And S is now going to take this, eat 1/2 of it, which is going to be 1/16. And then we could see the pattern. The next person will eat 1/2 of it, which is 1/32. So technically, this is what's just happening here, plus 1/64. Let's do it one more round. Half of 164. What is 64 times 2? Technically, 128 plus 102.56 and plus, so 1512 and so on. Okay, so you see now, there are two ways to do this. Before we start answering the question, to go from each number to the next number, we need to multiply that by 1/8. So you have 1/16. If you multiply it by another 1/8, then you're going to get 128. So we're going to call that one common ratio, right? Each time, each of these numbers, like this one, times by 1/8 is going to be 1/32 every time for every one of these people. So the question is asking how much S would eat, right? So let's call this one X. But why do we call this one X? Because it's the smallest amount, right? R would eat the least amount. Everybody else will eat more. So this one, look, if this is X, what happens if I multiply X by 2? So what is 2X? 2X will be 2/8 will be 1/4. 2/64 will be 1/32. And oh, the next one is this. So you see now, D is actually 2X. Oh, interesting. And now let's also do it. What if we multiply this fraction, which is X, by 4? We're going to get the next person. 1/8 times 4 is going to be 4/8, which will be simplified into 1/2. The same thing is going to be 4/64, we simplified into 1/16, and so on. So we could see now, so take a look. So that means, Okay, this is just 4x. That means D will eat 2 times of R, and S will also eat 2 times of D. So, and we know together, they just eat one cheese, one block of cheese. All of that is just 1. So that means x plus 2x plus 4x is going to be just 1 block of cheese or 1 cake, whatever. So 1x plus 2x plus 4x is equal to be 7x is equal to 1. X is equal to 1 over 7. And the question is asking for Sarika. So that's going to be 4 times of this, which is 4x is going to be 4 over 7. So it's going to be this. Okay, that's method number 1. Now let's do method number 2. Imagine you don't want to analyze everybody else. We don't have to, right? So what if somebody asks us, what is the sum of these numbers? And we don't want to know how much everybody else is eating, right? So we should be able to do this real quickly. So let's find S now. Look, so look, I'm going to call this one X. So X is equal to 1 over 2 plus 1 over 16 plus 1 over 200, 1 to 8, and so on, right? So all we need to do is multiply both sides by the common ratio, right? The common ratio is this: everything is being multiplied by 1 over 8. To go from this one, you need to multiply by 1 over 8. So we multiply everything by the common ratio once. So we're going to have x over 8 is going to be 1 over 2 multiplied by 1 over 8 is 1 over 16. Okay, 1 over 16 times 1 over 8 is going to be 128. Okay, and so this is good enough. And look, by the look of these equations, we could find x quickly. Why? Because this part is exactly this part, isn't it? So that means instead of whatever this is that will go forever, it will continue forever. But all of this is actually x over 8. So I'm going to clean this part because all of this was equal to x over 8. So I'm going to write x over 8. That's it. So now let's find the value of x. So to do that, what is the least common multiple of 1, 2, 8? It's just 8. So let's multiply everything by 8. X times 8 is 8x. 1 over 2 times 8 is 8 over 2, which is 4. And this is just going to be x. 8x over 8 is just x. So let's take this x to the left. So we're going to have 8x minus x is equal to 4. So we're going to have 7x is equal to 4. So x is equal to 4 over 7. Remember, this is for the previous question, so we shouldn't confuse them with that one, right? So that means the value of this 1 over 2 plus 1 over 16 plus 1 over 200, and if it continues forever, is just going to be 4 over 7. And we managed to do it in 2 different ways, okay? So use whatever you like. And I'm going to give you again another question you could do at home. So wherever you are, so if you're in your room, you're at school, imagine you just go 5 meters. And then after that, you go 1/2 of this, 5 over 2. And then you go half of that again, 5 over 4. And then you go half of the previous amount, which is 5 over 8. If you do this forever, right, for eternity, more and more and more, what is the total distance you would go, right? You would do that forever. But how far would you go? Write it in the comment section below. Okay, to do this problem 21, there are mainly two challenges. One is that we need to understand the problem. It's not easy to understand. And second, where to start, right? Because we have a lot of letters and the numbers, the place to start is the most important thing. Okay, now let's read the question, try to understand it. So the K school has assigned grades 1 through 7 to pods A through G. 7 letters, 7 numbers. 1 grade per pod. Some of the pods are connected by walkways as shown in the figure below. Okay. The school noticed that each pair of connected pods, for example this, has been assigned grades differing by 2 or more grade levels. For example, grades 1 and 2 will not be in the pods directly connected by a walkway. So it says this is 1, this cannot be 2. Okay, so if this one is a 4, this cannot be a 3 because the difference is 1. This cannot also be a 5 because the difference is 1, but other numbers are fine. Even difference of 2 is okay by differing 2 or more. So 6 is also okay. 7 and 4 are 3, right? Okay. So what is the sum of the grades level assigned to the pods C plus E plus F? This is what we're trying to find. Okay. So hopefully we understood the task. We just want to put these numbers. Okay. The difference 2 or more. Okay, and now where to start? Okay, let's take a look at the pods that we have. Look, this one is, for example, D is connected by 2, like 2 walkaways connected this. G is also connected by 2. What's after that? We have something connected. E is 3, connected by 3. Okay, and then A is connected by 4 more. And lastly, C is connected by 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Okay, so where to start? So is it good to start from D because it's only 2? Okay, or is it good to start B because it's in the middle? The answer is no, these are not good options. Because, so for example, if I put a number like 4 here, right, a lot of options there are. I could put here 1. I could put here 2, okay? I could put here 6 or 7, and these are also 1, 2, 6, 7. So if I put 4 here, which one for C, which one for E? Too many options. That's a bad lead, that's a bad start. So what we want to do, we want to start with the place that has the most restrictions, right? And that would be C and F, right? So let's explain it better. Let's go down and write all these numbers here. So for example, if I put a number random, I'm going to go with 4. So for these places that are connected to it, I can't put 4 because I already used it up. For example, for G, because it's connected to it, I can't put 3. For example, for all of these, for this one also, I cannot use 5. So these are out. But now all of these are connected to it. 1, 2 is connected. This is connected. This is connected. This is connected. I have 5 circles, 5 letters, and I have 4 numbers. So I put here 1, I put here 2, 6, 7. You give me the next one. There is none. So this number cannot be 4. So we did it all wrong. So 4 is not possible. Let's go back now. 4 was a bad option. Do you think if I choose 3, would that change a thing? Or 5? No, because they're all in the middle. We need to start with the most extremes. So, for example, if I put a 7 here, for example, then all these options are okay. Only 6 is not okay because the difference is 1. I'll have 5 numbers. I have 5 circles. It's very good. Now the question is, I have 2 numbers. I have 2 letters. Which to which? CF. It doesn't matter. Why? Because, for example, let's see, this is 7, this is 1. I put a 7 here. I put a 1 here. 7 plus 1, 8. If I put 7 here, 1 here, 7 goes here, 1 goes here. So because we're going to add them all later, it doesn't matter, right? So the questions are designed well, right? We just have to find the correct answer. I'm going to choose a 7 here and then 1 here. So one more step, we're almost there. So now which ones are connected to C and F at the same time? So for example, G is connected to F. Okay, but is it connected to C? No. So let's not focus on those. A is between C and F connected. B is connected. E is connected. So these are the ones we want to focus on. Okay. Now for these 3, we already used 1 and 7. Because they're connected to 1 and 7 at the same time. So 6 and 2 are not possible. If this is 1, how can this be 2? Directly connected. So no. Okay. If I put 6 here, 6 and 7 directly connected. No. So look what happened. We have 3 letters and we have 3 numbers. So, I mean, they have to go somewhere. What if I just write them like this down? 3, 4, 5. Is it possible? You see it, don't you? Because 3 and 4 are directly connected. No. So the only way that is possible is to put 3 and 5 here. 3 here, 5 here, or 5 here, 3 here. Does it matter? No, because these are not in the answers. We don't care about A and B. So we'll put them somewhere. 3 here, 5 here, 4 goes here. So the answer is 1 plus C was 1. Yes, E was 4. F was 7. Just 12. So remember how we did it? We write things down as much as possible. And also, we start from the most extreme. The ones that gives the most restriction, right? Like F, like C, because they're connected to too many. Okay? So that's enough. Okay, problem 22. Maybe we actually understand the problem, but we don't know how to start doing this, right? Where to start. Okay, so I'm going to show you exactly how to start a question, break it down. So let's read the question. The classroom has a row of 35 coat hooks. P likes coats to be equally spaced, okay, so that there is the same number of empty hooks before the first coat, so 2, after the coat and after the last coat, and between every coat and the next one. Suppose there is at least 1 coat, okay, and at least 1 empty hook. So we can't just have, okay, all 35 coats cannot be on. How many different number of coats can satisfy P's pattern? Okay. So the problem we have, and the problem you have if you find this question difficult, because you start doing it from 35. I mean, what if the question said 43? What if they said 1001, right? We don't have to start with the number given by the question. We could start with easy numbers. Let's just start analyzing it. So what if we have, instead of hooks, I'm going to put like lines like this, easier to draw. And instead of coats, I'm just going to write C. So what if we have only 3? We have only 3 hooks. Can I have C, C, C? No, because I need an empty hook. Can I go C, okay, empty space, C empty space? Does it satisfy what the question's saying? The same number of empty hooks before the first code, yes, 1. And after the last code, 1. So there is no between every code, so it's okay, right? Now, can I put C here and C here this way if you have 3? Again, no, because we need empty space before it to be. There's nothing here, but after here there is 1. So if you have 3 codes, the only option possible is this. Now, what if we have 4 hooks? Where can I put the C's here? No. Can I put C here? 2 left, 2 right. So it's not going to work with 4. So it's going to only work with odd numbers. That's why the question gave us an odd number. If it gave us even, then we wouldn't even have 1. So what is the next odd number? 5. Can I have C here? Yeah. 1 space here, 1 space here. That's one way. What else is possible for 5 spots? What do you think? I would put C here and C here. This is also possible, right? Empty space, code, empty space, code. Okay, let's do a little bit more. What if it's just 7, 4, 5, 6, 7? Of course, as you see, this always works. 3 to the left, 3 to the right. Now, what if I have 3, 4, 5, 6, 7? So what if I put C here and here and here? How about that? Okay. So what if I have 1 code? It's possible. Can I have 2 codes? Right? Let's just try that. What if I have 7 spots? Can I have 2 codes? If I want to have 2 codes, I could put here 2 space, 2 space. Oh, that's not going to work, right? So there is no way this will work. Let's analyze it better. Why? When we have 7 hooks, we can have 2 codes. Look, we have 7. Of these 7, 2 of them are codes. So minus 2. Then we'll have 5 of these hooks. Let's call them hooks. But as you see, we're going to divide this by 3. Can we divide 5 by 3 evenly? I mean, we have to break one of the hooks so that we could divide it. Not possible. So that also gives us a clue on how to do a bigger question. So this one is not possible, right? Okay. I'm going to keep this one. And now, with knowing this, let's try to break the question down. So now that we have 35, right? Let's go with this one. I will have 17 to the left. These are 17 hooks. 1 code, another 17. So 17 plus 1 plus 17 is 35. So that works. Now let's see, can I have 2 codes? So 35, 2 of them are going to be codes. If I have 2 codes, how many spaces do I need? I need 3 spaces, right? So 35 minus a 2, because codes are 2, 33. Can we divide 33 by 3? Yes, 11. So that's the next answer. See, when you start it, well, the question is easier. Now it's just basically a trial error question. You just need to be patient and careful. So we're going to get it. Now, can we have 3 codes? Look, so C, let's just write here, C, C, C. So then I'm going to have 4 empty spaces, 35, 3 of them are codes. I'm left with 32. I divide this by 4. I'm going to get 8. Yes, it's possible. Good. Now, can I have 4 coats. Then it's going to be 35 minus 4, 31. Can I divide 31 by 5? No. So not possible. Let's go with the 5 coats. 35 minus 5 coats. 30 are left. I need 6 spaces. 5, yes, it's possible. So I'm going to have 1, 2, 3, 4, and 5. Yes. So that's why we did 30 minus 5. We need 6 spaces. 1, 2, 3, 4, 5, 6. So 30 divided by 6 is a 5. And you see the numbers are dropping. Look. So there's not going to be a lot more because 17, 11, 8, 5, not more because we can't have 0. We can't have -1, right? The options are not many left. So let's push a little bit more. So now let's see. 35. Whoa, what is the next number? So 35 minus a 6 is a 29. 29 is prime. I'm not going to bother with that. So how about 35? Okay, minus 7, 28. So I'm going to have 8 spaces. It will work, right? No, it doesn't work actually. Yeah, I got excited for no reason. Yeah, it's divisible by 4, so I'm going to have 3.5. It's not going to work. So, no. Let's go 35 minus 8 is 27. Yes. 27 divided by 9 spaces works. It's a 3. So, this one's going to be a little big to draw, so I'm going to go with 8 coats. So, you have to draw it small. 2, 3, 4, 5, 6, 7, 8. Of course, when you're doing the test, you don't have to draw all these. I'm just doing it to make it visually easier for everyone to see. 3, 3, 3, 3, 3, 3, 3, 3. Okay, so maybe there would be a 1 or there would be a 2 now, right? So let's see what the next numbers are. So we already did. So let's continue this more. I'm going to use the space here. 35 minus 9. Okay, it's going to be 26. Is it divisible by 10? No. So then 35 minus by 10 is going to be divisible by 11? No. 34 minus 11 is going to be 23 prime? No. So 35. Yeah. Okay, wait a second. So I might have made a mistake here. So 35 minus 11 is going to be a 24. Yes. Well, is 24 divisible by a 12? Yes. So we found the other one. So it's a 2. So I have to draw 11 C's. So, but I'm going to do it nonetheless. So I'm going to draw actual 11 C's in 12 lines. C, C, O, C, 4C, 5C, 6C, 7C, 8C, 9C, 10C, 11C. So, and then I'm going to put the numbers here in these spots. So it was just a 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. And I think the next one requires no calculation because we're going to have one space between them, right? So, and the spaces are always one more. So the last one will be 17 seeds and 18 spaces. That's the only final work. So I'm going to have like 17 C's. I'm not going to write it. That's going to be huge, right? And between them, we're going to have 18 spaces, right? So this will be the final one. Maybe we could also do that. I mean, we drew it all. Let's go and finish that one too. The last one, we're going to go draw 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, right? And between each one, we're going to have 1, and these are going to be one more, which is 18, and 17 and 18 is going to be 35. Of course, so if I wanted to draw, or to make it visual, I think it's okay to make these visuals. But after that, you could just write numbers, right? Or like record them some other way. So as you see, it's going to be 1. Let's count. 1, 2, 3. Okay, 5, 4. This is with the 5, 4, 5, 6, and 7. So the answer is just this one. Okay, let's do problem 23. This is one of the most difficult questions of this test. And it's difficult because you need to be good at prime factorization and you need to be good at the difference of the squares. If you're not good at any of these two things, I don't think we could answer this question. So let's go and practice a little bit of both. And then we're going to come back and deal with this problem, okay? So first of all, let's see what we mean by the difference of squares. If somebody says a squared minus b squares and we want to factorize it into 2 parentheses like this, do we know the answer? Well, all we have to do is write these two and multiply them together. Look, when we multiply them, the first one, this is how it happens, right? This is going to give us the two terms, like a times a is going to be a squares. A times b is going to be plus ab. Now, negative b times a, negative ab, and negative b times positive b, negative times positive is actually negative b squared. And look what happens. ab and ab cancel. So it's equal to the a squared minus b squared. And this is right over here. So that means this is also equal to a minus b, okay, times a plus b. Let me write it better. But how is this even helpful? Well, it's very helpful. So for example, if you want to do 90, if somebody asks us to do 997 squared or multiply them together, you could use this identity or similar identities. Not quite this one. Now, this question is going to ask us to do perfect squares minus 1, right? A perfect square is like 25. So what is 25 minus 1, for example? Look, according to this identity, we could write this one as 5 squared minus 1 squared. So it's going to be 5 minus 1 times 5 plus 1. So which is equal to 4 times 6. How is this even helpful? Right, it's very helpful. Let me just give you another one. Let's go with another perfect square. 81. So for example, 81 minus 1, we could write it as 9 squared minus 1 squared. We could write it as, 9 minus 1 and then 9 plus 1. Okay, so how is this helpful? It is very helpful because you see the difference is always 2. 4 plus 2 is 6. And what if we have a squared minus 1, right? Remember, 1 and 1 squares are the same thing, so we're going to have a plus 1 times a minus 1. So it's very, very, very important because if we have a perfect square minus 1, right, we could always write it as 2 numbers with the difference of 2, right? If, for example, this one is equal to 10, this one is equal to 12, right? So you try it. So that's very helpful. So we could always factorize a perfect square minus 1 with 2 integers with a difference of 2. That's very important, okay? So that's the first thing we need to know. And there's also the second thing, which is, I'm going to change color. prime factorization. This question is asking us to write numbers as a prime number multiplied by another prime number. What numbers we can write, what numbers we can't write. So for example, prime times prime, like 3 times 7, like 7 times 11, right? It's okay. But a number like 42, can we write it as prime times prime? We know, for example, this number is equal to prime factorization of this number is 2 times 3, 6 times 7. Okay. 2 is prime, 3 is prime, 7 is prime. We can write it definitely as 3 different numbers, prime numbers multiplied together, but can we write it as 2? The answer is no, because if I put these two together, if I write it as 6 times 7, then 6 is not a prime number. If I write these two, so it's going to be 2 times 21, 21 is not a prime number, okay? So these two things are crucial in understanding that question. So, okay, now let's go and use what we have learned so far. How many 4-digit numbers have all the following properties? The tens and the ones digits are 9. So it's going to be a 4-digit number. The ones digit is 9. The tens digit is 9. We don't know anything about these. Now, the number is 1 less than a perfect square. So the same number that we talked about, if we add a 1 to it, it's going to be a perfect square. I'm going to write it as a square. This is this condition. And now the number, by the number we mean this. 99. We should be able to write it as prime times prime. So technically this question is a narrowing down question. Okay, so how many 4-digit numbers do we have? We know we have 9,000 4-digit numbers so far, right? But the question says that because of the first condition, like this is the one condition, I'm going to write it here. Because of the condition number 1, so we know that the last 2 digits are 99. So how many different ways can we put the last 2 numbers? Look, so with this condition, we have 0. Can I put 0 here? No. Can I put 1 and 0 here? Starting with 10? Yes. Can I put 11? Yes. 12? Yes. 13? Yes. 14? Yes. And then 2. 20? Yes. 21? Yes. 22, 23, 24. And then 99. So that is going to be only 19. So the condition number 1 from 9,000, right, candidates, we only have 90. Very, very important step. So now here it says, when we add these numbers plus 1, they become a perfect square. So for example, what if I go 1099? If I add a 1 to it, so it's going to be what? 1100. Is this a perfect square? No, because I could write it as 11 times 100. This one has a perfect square because it becomes 10. Well, what are you going to do to 11? Nothing. So what numbers do you think we can write here? What if I write 20? 99 is one of the 90 numbers here. If I add 1 to it, it's going to be 2100. I could write it as 21 times 100. This one has a perfect square, becomes 10. This one, nothing. So the only way for them to be like a perfect square with 00 is going to be a number like this. How about 40 times 40? Good. So the number has to be 1599 if this is the number. 1599. If I add 1 to it, this is going to be 1600. This is a perfect square because I could write this number as 16 times 100. Perfect square. Square root of 16 is 4. Square root of 100 is 10. So it works. So what numbers like this do we have? So we need to have only a few, right? Because now we want the values for a squared. What are the possibilities for a squared? Let's see. Perfect. So a squared could be maybe 40 squared, 50 squared, 60 squared, 70 squared, 80 squared, 90 squared, 100 squared. If I go more, look, 100 squared is 1, 0, 0, 0, 0, which is 5 digits. That's the maximum, right? So, and now look, these are the values of a squared. So how many numbers do we have now? These are just 7. So after this, we only have 7, we have, with the condition number 2, this condition, we only have 7 things to deal with. 40 squared, 50 squared, 60 squared, 70 squared. Now, if a squared, for example, is equal to 40 squared. So this is 1,600. Now, what is the number? The question here says the number. What is the number? The number becomes 1599 plus 1. Okay. Now, the number 1599, is it equal to prime times prime? Is it? How to do this part? I already taught you how to do this. I already told you. So we're not going to do prime factorization of this because we know 1599 is actually equal to 40 squared minus 1, right? So that means 1599 is equal to what? 1 squared is also 1. I could write it like this. 40 plus 1 times 40 minus 1. So that means 1599 is equal to 41 times 39. Is this prime times prime? This is a prime. Is 39 a prime? No, 39 is divisible by 3 and 13. So no. This 7 becomes 6. We try. We need to do it more, 6 more times. So let's repeat it one more time. Okay, so this 1599, which was about 40 squared, does not work. So let me change color. So this is not going to work. The next one is 50 squared, right? The number before that is going to be 2,499. We want to know if this number can be written as prime times prime. So let's just do the same steps. This number is equal to 50. I'm going to write it quickly. 50 plus 1 times 50 minus 1, which is equal to 49 times 51. 49 is 7 times 7. Is this a prime number? No. Bye-bye. Let's do it with the next one. The next one is 3599. Why? Because it's actually 60 squared minus 1. So 3599 is equal to 61 times 59. 59 is prime. 69 is prime. So yes. Okay. Now let's go. The other one, this is the last time I write it here, 70 squared is 4899 is equal to 70 squared minus 1 squared, which is equal to 70 plus 1 times 70 minus 1. 70 minus 1, this is 69, is not prime. It's divisible by 3 and 23. Bye-bye. So then the other one is 80 squared minus 1. So I'm going to write it this way. This is equal to 81 times 79. This is prime is good. 81 is not prime. 9 times 9. So bye-bye. Let's do it with 90 squared. 90 squared minus 1 is going to be 91 times 89. Okay, so so this one, let's double check. It's going to be, okay, 90 minus 1 times 90 plus 1. Well, look, this is a prime. Yes, this is very, very tricky because this one is 13 times 7. For a moment, I forgot. I thought it was a prime. So it's 13 times 7. 91 is not prime. Okay. Look, why did I write 100 squared even though 100 squared is 5-digit number? It's okay because now 100 squared minus 1 is actually, this one is 4-digit number. This is 5-digit number. This is 4-digit number. We have to check this one also. So this one now, 9999, we could write it as 99 times 101. This one is prime, but this one is not prime because it's divisible by 3, 9, 11. So of course not. Then this one is also not. So we only have this one. So the only, from all these 9,000 number, 97, there's only one number that satisfies all the condition. It was 3599. This is the only one satisfying all the condition. Well, 24. I think this problem is not that difficult. It's kind of easy. So let's deal with it. And the reason I think it is easy because it's isosceles trapezoid, right? So when this side is equal to this side, we always draw this, right? This is what we always do. We always make these two heights, draw these two heights. And now we have a 60, 90, 30 degree right triangles, which is a special right triangle. So I'm assuming that we need to work on special right triangles. Maybe that's the reason why probably you couldn't do this question. So let's go and review special right triangles because we only have 2, right? Well, the first special right triangle is made from a square, right? If I draw this one, look, if this one is, for example, 1, this one is equal to 1. So this is 90 degrees. Of course, this is isosceles, so these angles are equal. So the 90 plus these two should be 180. So these two should be 90. Since they are the same and congruent, so this should be 45 degrees and 45 degrees. Now let's check over. 45 plus 40, 90. 90 plus this 90, 180. That's it. And now you tell me what is the diagonal of a square. Look, let's call this one C. We know a squared plus b squared is equal to c squared, but in this case, a and b are the same, so we're going to do it like that. So now we're going to have 2 is equal to c squared, so then c is equal to root 2. Okay. Now I have a question for you. What if the sides of the square, or what if the question says this? You're supposed to find this and This is 999. This is also 999, right? Remember, this is a square. Look, are you going to go 999 squared plus 999 squared and then a square root? Because these two triangles are always similar. This has become multiplied by 999. So the answer is just 999 root 2. There you go. That's how it's done. That's the first special right triangle. We have only two. That was the first. Now let's go and deal with number 2. Number 2 is made of equilateral triangle. Look, this is not the best equals isosceles. Let's just have it better. I mean, it should be more like this. I think this looks better. So now if it's this is 60 degrees, this is a 60 degrees, this is a 60 degrees, right? And let's assume, for example, you give me, let's see, this one is a 10. So which means this side is also 10, which means this side is also 10. And now, what if I just plan to draw the height from here? Look, this is equilateral, right? Triangle. So that means the right side is symmetrical to the left, right? So don't look at my drawing. This looks bigger than this because it's inaccurate. So this one, that means this one is half. This one is 1/2. Equilateral is also isosceles. The right side is equal to the left side. So there you go. There you have it. Look, we're going to have a 5 here. So this is the special right triangle that we talk about. So now we know, let's just do it with the small one. So that means if I go, this one is 1. This is, well, I don't know what that is now. This is 2. This is the same ratio. Look, 10 divided by 5 is 2. 2 divided by 1 is 2. These are similar right triangles. This is also 60 degrees. So let's do it here. If this one is b, so we're going to have 1 squared plus b squared is equal to 2 squared. So 1 plus b squared is equal to 4. B squared is equal to 3. So b is going to be root 3. There you have it. So look, we're going to have this one is equal to root 3, 1, root 3, 2. Remember this forever because you're going to need this over and over and over, right? So in all parts of math in the future, school math, competition math, everywhere. Now look, 1 times 5 is 5. 2 times 5 is 10. Root 3 times 5 is 5 root 3. There you go. So that means this one is also 5 root 3. Look that we just copy and paste the root 3. What is the ratio? 1 to 5. So 5 root 3. So that's all we needed for this question. Now let's go and actually deal with this one. We're going to have this one here. Okay. So let's read the question. In trapezoid ABCD, angles B and C measure 60. Of course, AB is equal to DC. Of course, the side lengths are all positive integers. Very important. So this is an integer. And the perimeter is 30 units. Okay. How many non-congruent trapezoids satisfy all of these conditions? Why did they have to say non-congruent? What does that even mean? For example, one trapezoid could be like this, for example. I don't know, for example, what if this one is 8? This one is 8. This one is also 4, 4. So that's equal to 24. Oh, this actually would become so small. So what the question says, if, for example, this one is 1, if you draw another one with a different color, with the same length that we have here. So for example, this one is 8, this one is 8, right? If they all have the same numbers, right? If this side is equal to this side is equal to this side, this to this, and this to this, if completely congruent, count it once. Of course, we're going to count it once. So this question, what it's saying here is kind of obvious, right? If you were going to count every trapezoid infinite times, so the answer would be infinity. Okay, so let's go. What we just learned here, I'm going to draw this one. We just learned that the ratio, this one is going to be x. Look, the hypotenuse is 2x, not this one. This one was x times root 3. So this is also 2x. Now we're going to do it to the other side, here, here. So we're going to have x, right? This is going to have 2x. But this one, we need a different variable, right? So let's go generally. We want the perimeter. Y is this one. Y plus 2x plus x plus y plus x plus 2x is supposed to be 30. Let's write it down. So let's start from here. I'm going to write the base. 2x plus y is the base. 2x and 2x, I'm going to write it just 4x plus y is going to be equal to 30. So we're going to have 6x, right? Plus 2y is supposed to be 30. Now, we need to analyze this. Look, this one, y should be an integer, of course, because y is this side. If this one is 14.5, for example, the question says the side length, all of them. So y has to be an integer. If this one is an integer, like for example, 10, can x be 1/2? This one be 1/2? Yes, because now the total one will be 11. So x can be 1/2 things, but can it be 1/3? No, because now 1/3 plus 1/3 plus 10 is not an integer. It's not a whole number. No. So then for example, let's try. This can be, if this one is like x is equal to 1/2, this will be 3. Look, odd number plus 2y is even is going to be even again. So if I go take it to the other side, so 2y is going to be even minus odd. Even minus odd is odd. So 2y cannot be 27 or odd. That's never going to work. So none of the 0.5 numbers are going to work. So for example, it doesn't matter if I put here x is 1.5. 6 times 1.5 is equal to 9. 9 plus 2y is equal to 30. 2y will be 21. Y will be 10.5. It's not going to work. So that's relaxing, because now we know that x is just have to be an integer. And like it's okay. Look, this is even. This is even. This is even. So let's divide it all by 2. So we're going to have 3x plus y is going to be equal to 15. Now let's see. What if x is just equal to 1? If x is equal to 1, then y is going to be 12. That's one possible answer. If x is equal to 2, then y is going to be just 9. All right, that's the second one. If x is equal to 3, so 3 times 3, x equals to 3. Let me change my color here. So if x is going to be equal to 3, then y will be equal to 6. And if x is equal to 4, y is going to be 3. And if x is going to be equal to 5, y is going to be 0. Let's draw them. I mean, we already have 5 candidates, except the last one, which is 0. But we're going to draw it. Now, how about this one? Can y be 12 and x be only 1? Look, it's going to be like this. We're going to have a 12 and a 12, right? Something like this. 12 and 12. And then from here, we're going to have, let me change my color. We're going to draw a 1, another 1, because these are happen to be 60 degrees. So automatically, these will be 2, and this will be 2. Why not? It's okay. It's definitely okay. So this one will definitely work. Let's check the other side of the extreme. I mean, let's check the last one. What if y is very, very small, x is very, very large? Let's see if that works. So for this one, let's try y is equal to 3 only. So we're going to have a kind of a small line here. That's a 3. This is going to be another 3, right? Let's just make them both longer. So 3 and 3. Okay. And then x is going to be 4. So I have to put 2 bigger numbers here, a 4 here and a 4 here. Okay. So then this one will actually be an 8. So the reason this doesn't look like an 8, because this is not really 60 degrees, right? I had to draw it more like this. So that means this 3 had to go up a little bit, but generally it's correct. So 3, 4, 4, 8, 8. So that's going to be, let's just add them all up. I mean, why wouldn't it work? That's going to be 11, 14, and then 16, 30. Yeah, all of them will work. And what is the final case? What if x is equal to 5? If x is equal to 5 and y is equal to 0, it's going to look like this. If x is 5, this is going to be another 5. This is going to be 60 degree, a 10. Then again, another one. So the last case, when y is equal to 0, this is not called a trapezoid anymore, but equilateral triangle. So that's why of all the options, 5 options that we wrote, the last one is not acceptable. So this one, and this one. So if we are good at special right triangles, and if we know that in isosceles trapezoids, we're going to draw these lines always, then I think it was manageable, not that difficult. Okay, let's do problem 25. This problem is not as difficult as you may think. It's actually kind of easy if we do it the right way. Okay, so let's read the question. Michaela finds all the possible ways to draw a path 5x5 diamond shaped grid. Each path starts at the bottom, of course, and then at the bottom of the grid and ends at the top, always moving 1 unit northwest. Maybe like this, or maybe like this, maybe like this, or maybe like this. Okay. She computes the area of the region between each path. So for example, this is the path and the right side. This is the right side, right? This is the right side. So this is going to be the area. 2 examples shown in the figures below. What is the sum of the areas determined by all possible paths? Ooh, very difficult, because it's going to be how many paths and then how to compute all areas. Is it difficult? Well, my question to you is, why 5x5? I mean, they could have just asked 9x9, or they could have asked 23x23. If they ask 20x3x23, would you really go there and then draw a 20x23 thing? Is that what you do? Or you would think, okay, whatever pattern is, it's the same as 5x5 by 3x3, 2x2, 1x1. Why do we have to start with the 5x5? Because there is a drawing here. So what we do, we make the question simple for ourselves. we don't start by what they gave us. We start with a 2 by 2 square. And the other thing is that, why do we need to draw it diagonally? I think it's much easier to visualize a normal square. These are squares, right? So let's see. First, it's about how many ways can we go from this corner, the bottom corner, to the top corner. How many ways there is? One way is like this. So let me write it here. Okay, one way is like this. So let me draw it here. So it's going to be this one. Okay, and then another way is just like this. So, and look, every one of these has a counterpart. Look, this one is also this one. This is another path. I'm going to write them below so that it would be easier to visualize. So this is again another one. It should be written here. Yeah, this is another path. And finally, the other path is going to be like this. Okay, let's draw it here. So a 2 by 2 has only 6 paths. And now let's focus on the area. What is the area of this one? With the right side, nothing. Right? With the right side, it has nothing. It's the area of this is 0. I'm going to write it inside it. But if I go from here to here, with the right side, it's the full square. So 4. And now let's go with the other one, which is this. This is the area of this part. It's only 1. But what do you think is the area of its counterpart? Like this one. With the right side again, this is 3. And you can see, interestingly, the sum is always 4. Let's go with this one. That's a 2. Okay, with the right side. This one is also with the right side, which is this one, this and this too. Oh, that's a lot easier because you could put them into pairs and each pair is a 4. It's easy, right? We could even do it by a 3 by 3 if you think it's necessary. In a test, I wouldn't draw a 3 by 3 because I think we already figured out the pattern, right? If it's a 3 by 3, it's going to go the same way. I'm going to show some of them. Look, there is a path like this, which is going to give us the area of 0. Okay, so I'm going to draw something like this. I have to draw it a little, okay, like this. This would be an area of 0, but there would be this one giving us area of everything 9. So I'm going to clean it, so I will make a little mess here. So there would be here, there would be this one giving us the area of 1. There would be another one looking like this. Like this. This is area of 8, right? So that makes the question very, very easy. The only question remains is how many paths we have. So for example, for this one, a 2 by 2, we have 6 paths, right? 6 path is going to give us, divided by 2, sorry, it's going to give us 3 pairs, right? And each pair is going to give us the area of the square. So we have 3 pairs, each one is going to give us 4. The answer to this, the sum of all areas is 12, right? So, but how do we count the number of pairs? It's very easy, just listen to me. So, the number of pairs goes like this. Look, to go from here, we need to go right 2 times and up 2 times. That's it. So I'm going to write rights by R. I think I don't like the color. I can change it to blue. So R, up, represent this. R, right, up. What if I change the order of these letters? Right, up. Then it's going to be right, up. Oh, good. So now how about up, right, up, right. Oh, so I just have to calculate the number of rearrangement of the letters, right? So you could write them here. Let me just write them, all of them here. R, R, U, U. So we have R here and here, R here and here. So R could be in the first place and the last place. I'm not going to even write U's. There would be two U's here, right? Okay. So R. What if R's are both in the middle and the U's are here and here? And what if there has to be one missing? So first and third, fourth and two. Yeah. So what if R is in the second place and in the last place? Right? We don't, the rest are just already used. We know. So I'm going to put the use here. I just count the number of ways I could put here. So how is there a fast version of doing this? Yes. So two ways. You could say I have 4 letters, 4 factorial. Then I have 2 R's, 2 factorial. I have 2 U's, 2 factorial. Or you could think of it, if you know combinations, you could say, okay, this is just, I have 4 spots and I need 2 R's, maybe here and here. So I just need to choose 2 of these spots for my R's. So that is going to be 4 choose 2. There you go. So let's do it for a 3x3 for extra practice. A 3x3 means we need to go 3 rights and 3 ups. So we need the number of rearrangements of these letters. So it's either, you could write it like this. I have 6 letters. R's are repeating 3 times. U's are repeating 3 times. So we need to simplify this. That is 6 times 5 times 4. Look, if I divide this by this, it's going to be this. Think about it. And then this 3 factorial is just 1 times 2 times 3. This cancels this, so it's going to be 20. So I have 20 path. So that means I have 10 pairs, right? And each pair will give me the area of 1 square. So the area of the total area of everything will be just 19. Okay, that's too small, isn't it? For a 3x3, it's going to be small. One last time, we're going to do it by a 5x5. So let me undo everything. For a 5x5, just think about it. How many R's do we need? How many U's do we need? 5 ups, 5 rights. So we need the number of ways we could rearrange these letters. So that is going to be 10 choose 5. Or you say, I have 10 letters, I have 5 R's, I have 5 U's. We need to simplify this. Ooh. So I need a little space. So this and this is not 2 factorial, right? It's 10 times 9 times 8 times 7 times 6. Why? There was a 5 times 4 times 3. There was a 5 factorial here. They already cancel each other out. That's why there's a 10 times 9, 8, 7. Okay, divided by a 5 factorial. Let me write it 5 times 4 times 3 times 2 times. Let's just write 1. Look, so let's just simplify. The 6 simplifies 1 times 2 times 3. And there you go. There is a 20 here. And there is 10 times 8, 80. 80 divided by 20 is 4. So I'm going to cross this, cross this, cross this. So it's going to be a 4. So the number of paths that we have are 4 times 9 times 7. That's the number of paths that we have. We need the number of pairs. So pairs, we just have to divide this number by 2. That's going to be 2 times 9 times 7 is the number of pairs, right? Okay, this was the number of paths. So we have this. We know each one for this one was 1 plus 4. But for a big one like this, it would be 0 plus 25. This would be 1, the other would be 24. So we're going to have this many, 25. So where to write it? I'm going to write it below here. So we need, this is the number of pairs. Each pair is going to be a 25, right? So this is equal to 9 times 7, 63 times 50. I like to do it this way. I like to do it 63 times 100 over 2. That's how I like to do it. This is going to be this. So what is half of 6,300? That's 3,150. Okay. So it's going to be this one. So what do we learn about this type of question? There is a general pattern. We shouldn't start by a 5 by 5. You should start by a 2 by 2, even 1 by 1, 2 by 2, 3 by 3. Learn how the question is solved. Learn the rule, apply it to the bigger question. Okay, that's the end of this video.